Welcome to the Podkey Summary of Privacy and Security Group Lab from WWDC 2026. Apple's latest privacy and security story is really about one idea. If AI is going to touch personal data, the guardrails have to be built in from the start. A lot of that centers on private cloud compute. How Siri handles context, what happens when third-party models enter the picture, and a bunch of practical protections around encryption, memory safety, passkeys, and telemetry. It's technical stuff, but the theme is pretty simple. Apple wants more of this protection to happen by default, not only when a developer remembers to do the right thing. One of the more interesting warnings here is indirect prompt injection. That's the problem where an AI agent reads some untrusted content, like a document or web page, and that content tries to steer the model into doing something it shouldn't. Apple frames this as part of what it calls a lethal trifecta: access to private data, the ability to take actions, and untrusted context all mixed together. If you've got an agent that can read your stuff, click buttons, send things, and it's also taking instructions from a potentially malicious source, you can see how that gets messy fast. Apple's answer is a blend of deterministic and probabilistic defenses. In plain English, some actions need clear user confirmation every time, and some risky situations get surfaced through UI highlights that help people notice when the model may be going off script. They're also pushing this out to developers through a WWDC session focused on securing agent features, which feels important because a lot of these mistakes are going to happen at the app layer. Private cloud compute is still the centerpiece here, and Apple keeps describing it in unusually strong terms. The two big guarantees are stateless computation and non-targetability. Stateless means requests are processed without lingering data sticking around on the server afterward. Non-targetability means user requests can't be singled out in some special, custom way. The system is designed so Apple can't quietly aim a different server behavior at one person. The data is handled on nodes that are isolated and ephemerally wiped, and Apple says even a reboot leaves no persistent trace behind. There's also hardware attestation from multiple vendors, which is Apple's way of saying, don't just trust our slide deck. Verify that the machine running this workload is the machine we said it was. The part that makes this more than a marketing promise is the verification environment. Apple is releasing a downloadable virtual machine that mirrors the PCC server software, so independent researchers can inspect what's supposed to be running and compare it with what's actually attested in production. That opens the door to real-time checking, bounty work, and continuous outside scrutiny. And if an unauthorized software change showed up on a node, attestation is supposed to catch that. For a company that usually likes sealed boxes, this is a pretty notable transparency move. There is an important limit, though. Apple's PCC guarantees do not automatically carry over to external models from companies like Anthropic or Google. So if a developer pipes user data out to a third-party AI API, that's a different trust model entirely. Apple's message to developers is basically, read those terms carefully and tell users what's happening. By contrast, when developers use Apple's foundation model APIs with PCC, the data is used only for that specific request and isn't accessible to Apple or other parties. That distinction matters a lot, because people hear AI feature and tend to assume the privacy rules are all the same. They're not. That same split shows up in Siri. Apple says Siri uses on-device processing whenever it can, and private cloud compute when it needs larger models. Access is fenced in with entitlements, sandboxing, and TCC, so third-party apps don't just get a free look at whatever Siri knows. User consent is part of the flow too, including optional things like location sharing. And in multi-turn interactions, only the context that's actually needed is supposed to be sent to PCC, with the system able to reject requests if the context looks unexpected. That's one of those details that sounds dry until you imagine an assistant slowly collecting way more than you meant to share. On transparency, Apple is leaning hard on App Store nutrition labels. Developers have to declare all data collection, including data sent to third-party services, and the whole point is to make privacy practices comparable at a glance, like nutrition facts on food. It also puts some accountability pressure on developers, because those labels are supposed to reflect the real data flows. Behind the scenes, Apple is also pushing telemetry minimization. The guidance is to collect only what you need to answer a specific question, aggregate on-device when possible, and avoid overly detailed data like exact timestamps, if rougher data will do the job. For cases where broader insights are still useful, Apple points to tools like private Fed-ready learning and differential privacy, with mathematical guarantees that aggregated results can't be linked back to a person. That's not the glamorous part of AI, but honestly, it's where a lot of trust is, either earned or quietly lost. A quieter but very consequential change is in Apple's network framework. Since iOS 26, post-quantum-ready cipher suites are the default, so internet traffic gets upgraded without developers needing to flip a switch. Apple says that shift is already visible in a measurable increase in post-quantum traffic, which is a very Apple move. Make the secure option the boring default and let adoption follow. On macOS, there's also hardened runtime protection, which helps stop other processes from reading an app's memory or injecting code. And for developers handling secrets, the advice is straightforward. Use CryptoKit and the secure enclave instead of rolling your own crypto setup. That gives you memory zeroing and hardware-bound keys, which is a lot safer than a homemade encryption adventure that starts with confidence and ends with an incident report. Apple also introduced a Signal API for passkeys, and this is one of those small-sounding additions that solves a real lifecycle problem. Apps can be informed when a passkey is stale, revoked, or expired, which helps keep things cleaned up safely in the Passwords app. It fits into the broader passkey standard too, with coordination across companies so syncing and account state stays seamless instead of drifting out of sync. Security is always nicer when it includes housekeeping. Nobody gets excited about cleanup until the clutter breaks login. The through line in all of this is pretty consistent. Minimize what gets collected, tightly control what leaves the device, and make the cloud side verifiable when it has to exist at all. Some of these protections are deep in the plumbing, but they shape whether AI features feel safe enough to use in everyday life. And for once, the fine print is kind of the main event. This episode was generated by Podkey. Create your own at podkey.fm.